We're going to go ahead and show you from this point on how to even take an existing chuck lighter and turn it RC. This is a point where you're going to need to have your APAC in order, which is the 1806 motor. You're also going to need to build an additional part, and you're going to be using a razor blade. So for this build, before we get started, we're going to be using two 5-gram servos, and we're going to use the shortest servo arms that come in the servo kits. So because this design is going to need a power pod, we're going to go ahead and build one. Now, one thing that's a little bit different is normally our power pods are removable. In this case, this is going to be a permanent fixture, which means if you're going to want to take off your motor, you're going to need to remove it from the airplane. Let's go ahead and use the same trick that we did before. Drag a gift card down through and pull out the cavities. And if we look at the diagram, we're going to notice that this is an A-fold. A-fold is where the side cheeks go above the bottom plate, A for above. So we're going to go ahead and apply glue to this portion here, have this resting against the table, and then fold this inward. If you have any residual, we can just squeegee some of that out. We're going to repeat the same process on the other side, and take your time to make sure that each side is perpendicular. Now, if you bought the RC version speedboat kit, you're going to get included a little control horn / firewall combo. Go ahead and crack out the firewall, and that firewall is going to get glued into place right on the top here. After the glue is thoroughly dry, we're going to go back and we're going to wrap it with tape. Go ahead and put a healthy amount of glue on the very facing edge that's going to meet the firewall. Set that down in place. Don't worry if it squeezes out just a little bit. Give it about 15-20 seconds of drying, and then we can go back and remove the extra glue. Once the glue is thoroughly dried, we're going to go ahead and wrap this whole thing with tape. The tape is actually going to be where most of your strength comes from, so don't neglect this step. We're going to split the middle here. I'm going to fold it down. And then just like wrapping a gift, we're going to fold the edges in. We can then go back and trim off any excess if we have any. Now, an important step not to neglect is to remove the center section here. If you leave this on, what you're going to notice here is that your motor's not going to be able to spool up. Brushless motors are very powerful, but they have very low torque. So if it has anything that keeps it from spinning easily, it's going to cause the engine to stall. Also, go ahead and just pop little holes here and here. Our next step in the RC conversion is to mount the motor. Now, one thing I cannot stress enough is you're going to have a whole bunch of different size screws. This motor is predominantly used for multi-rotors, and sometimes you're going through thicker arms, so they give you lots of screw options. But one thing you got to make sure is pick the very shortest screws that you need. So that's going to be these ones right here. If you put too long of a screw in, you're going to end up driving the screw into these metal windings. It's going to ruin your motor for you and break it. So we got our shorter screws. We're going to go ahead and only use 2 of them. We're going to put the rest aside. You can save them or discard them however you wish. We're going to go ahead and pass the screw through the hole. Now in this case, because we want this to be serviceable, we're going to actually pass the wires on the outside and tuck them down in to go along the side of this area. So we're going to line up the farthest out holes on the motor mount, and we're going to make sure that our wire leads either go to the top right of the motor pod or the top left. In this case, it's going to be the top right. We're not going to screw this tight just yet. We're only going to get it slightly loose. Now we can take the next motor screw, pass it through, and find the hole. Once you have it threaded and everything is going nice and neat, go ahead and tighten it down. Once again, making sure you're using the shortest screws. Our next step is to mount the power pod. Before we mount the power pod, go ahead and remove the wings and also loosely fit on your prop. The prop is going to be very important. We highly recommend using a 5-inch, but if you have our stock 6 inches, that's just fine. We're just going to want to place the motor so it doesn't come in contact with the tail. Our next step is to go ahead and make some indicator lines. We're going to want to mount this motor so it doesn't come in contact with the tail. So move it just slightly back until it just misses. If you do by any chance have this too far forward and does come in contact, no big deal. You're just going to have to remove a little bit of material from the tail. Now, one thing you're going to notice is you're not able to put this in crooked. If you just put nice equal pressure down and split the difference between the hinge lines on both parts of the elevator, you're going to have this perfectly centered because of the natural groove of the shape of the tail. With a razor blade and our motor properly spaced, we're going to go ahead and put some indicator lines where we need to cut out a piece of the tail to allow the power pod to go all the way through. On the back, all we simply need to do is follow it up to the score cuts that we made on both sides. Once again, unfortunately, this is not going to be a power pod that you can remove. It's going to be permanently fixed. Once we're happy with the placement of our indicator lines, we're going to go ahead and holding the razor blade 90 degrees to the fuselage, we're going to go ahead and lightly cut this out. Have it take a couple passes so you don't do any damage to the foam below it. Before we glue our power pod in, we're going to go ahead and fold this over 180 degrees and cut or sand our bevel lines in order to make our hinge line. If you guys don't want to use razor blades for this step, we have a really good episode showing you how to build an entire speedboat kit without the use of razor blades. It uses a sanding block instead of this. To make the hinge stronger, we're going to go ahead and put a thin bead of glue right on the hinge line. And then before the glue sets, we're going to take a scrap piece of foam and we're going to scrape it all off. This is going to make a very, very strong hinge line that'll take lots of crashes in the future. We're going to do this on both sides. Let this thoroughly dry before closing the hinge. Now that our hinge lines are cut, we're ready to install our pod. We're going to go ahead and place the pod and make sure that we're happy with the spacing. If it needs to go further forward, you can always make trimming. We're also going to make sure that it sits nice and flat against the bottom plate here for both strength and alignment. Once we're happy with that placement, we're going to go ahead and apply a nice bead of glue on the bottom of both surfaces. I'm going to set this down in place. Smear, a little pressure. Once this is thoroughly dried, we can go back and put a nice thin bead of glue on both sides of the elevator. And as always, you can go back and scrape off the excess. One thing that's a little bit different about this design is depending on whether you're flying it with FPV gear or a bigger battery or a smaller battery, you may actually need to put a little bit of nose weight. So the more weight that you can remove from this tail area, the better off you're going to be and the less nose weight you're going to have to add. Optimally, this balance is perfect with a 1000 milliamp 3 cell, but if you have FPV gear and or a smaller battery, you may need a little bit of clay up in the front. Now you're going to notice on your kit or on the plans that you're going to see an etch line right along each side here and here, very, very lightly. Now this doesn't need to be perfect, but what we're going to want to do is we're going to want to go ahead and cut a score line, just line it up with those lines on the back side. If it's a little bit off, don't worry about it. Now if you have the speed build kit, we're going to have 2 push rods supplied with the kit. It's going to be way longer than what you need, so we're going to need to trim them down. But before we trim it down, we're going to pass it through this area. You can also use the tip of your push rod. Make sure this is nice and open. You don't want it to bind here. Pull this up and through. With our push rod passed through, we're going to take our control horns that are supplied in the kit, and we're going to snake them through the push rod. Let's give it a test fit real quick. Once we're happy with the fit, we're going to go ahead and put a little dab of glue right down on here. And then we're going to press the control horn through one last time. Make sure that you have a very good joint between your control horn and your elevator. If you lose that control, you're not going to be able to fly the airplane. Give this a good 30 seconds to dry. With our control horn thoroughly dry, our next step is to install our servos. Now the nice thing about this is we're going to go ahead and bring this to neutral on its own, which means we don't have to actually cut this to a perfect length, but we do want to give ourselves enough room to make adjustments. So the way I'm going to actually mount this is kind of contradictory to the way I used to do it. Normally I focus on pushing things up towards the nose. In this case, I'm going to focus on pushing things towards the back, so the lead comes to the back here and the receiver rests right over the center of gravity. So that means in this case we're going to want to make our first bend for our control horn right about here. We're leaving about 1/4 of an inch between the edge of the servo and the doubler of the fuselage. Now we're going to carefully take this and we're going to go ahead and bend this straight up. Once we have that bent straight up, we're going to grab this at about 2 millimeters or so. We're going to grip it down tight and we're going to bend it 90 degrees over. This is called a modified Z-bend. Big thank you to Kevin Teschner who sent these to me a year ago or even more. They're still working very good. Now I'm going to go ahead and cut this off and we're ready to install our servo. Before we install our servo, we're going to remove the sticker. We don't want to glue the sticker to the fuselage, we want to glue the servo. So we're going to peel this off. It's really important to make sure you scratch up the surface with either razor blade or sandpaper to give this something to have good adhesion, because the plastic is pretty fatty and it won't glue well on its own. If you do use sandpaper instead of scratching up with a razor blade, make sure you clean off the surface so the debris doesn't cause the glue joint not to be strong enough. Our next step is to lace a servo arm into the push rod. Now this servo has already been pre-centered. If it knocks out of center, go ahead and recenter it before doing this step. Now, depending on where we glue our centered servo, we can adjust this to perfect neutral. We're also going to make sure that our servo sits low enough that our wing's not going to come in contact with it. Apply a little bit of glue. Slide it back and forth just a little bit. Make sure it's recessed down nice and low. Don't put too much binding on here. We're going to slide this until the elevator is perfectly level. If the arm is too long, go ahead and trim it just a little bit shorter. This side is all done. We're going to repeat the exact same process on the other side now. If you find this space a little bit more crowded than your comfort, you can easily go ahead and turn this from a modified Z-bend to a standard Z-bend by just tilting this slowly 90 degrees. Don't do it too fast or it'll break your wire. With our servos done, our next step is going to be to install the ESC. We're slowly switching from JST to XT30. There's a couple reasons behind that. The JST connector can be forced to be plugged in backwards and also can't be soldered to its high gauge wire. The XT30 is safer, more durable, and also goes in line with the XT60s we have on our bigger power packs. We're going to have adapters in the near future, and all of our 8-packs that have the new XT30 will also have the extra pieces like JST adapter pieces that you can use to solder and make your own adapters. Now, before I did this step, I went ahead and took off the prop, and I also taped down the very back edge of the ESC wires just so they don't get in the way of our control throws. And depending on the length of your wires, I'm going to go ahead and just tuck these underneath this barbecue skewer just to keep it routed so the wing goes over it nice and neat. I'm going to go ahead and make my connections. It doesn't matter which way you go. We can always change the rotation later. Our next step is to make our connections into our receiver. Now the receiver we're using is a GR12L. It's a full range receiver from Grapner. Our first wire that's going to go in is going to be our throttle, and that's going to be in port number 1. Now we're going to take notice here that the negative line is on the very top. So if we take that down and plug into port number 1, the brown or the black wire is always going to be facing up. That's going to stay the same with all of our other servo channels. The next 2 channels to go in will be channel 2 and channel 3. Now when we go in and we check our directions, if these are backwards, all we simply need to do is plug them into the opposite port. So 2 goes to 3 and 3 goes to 2. We're now ready to bind. I haven't bound this receiver yet, so all I've done is I've went ahead and named the channel Sparrow. The next thing I'm going to do is I'm going to go ahead and go to transmitter control. I'm going to supply power, and I'm going to go ahead and press down the set button for about 6 seconds. The light's going to go off. I'm going to touch bind. And I now have power. One thing that's important for this, though, I do need to go ahead and tell this it has V-tail mixing. I'm going to go ahead and cycle the power. I'm going to power it back on. I'm going to go ahead and turn off my RF signal off. I'm going to touch my model. Now I'm going to go ahead and go in here and I'm going to tell it that it has delta mixing. So wing type will be delta. And I have 2 ailerons. Electric, enter. Every model is different. I just wanted to walk you through the same procedure with the MZ24. So now I can go ahead and power this on. And I can also turn on my RF signal back on. Now you're going to notice that my signals are backwards. So just like we talked about earlier, I'm going to go ahead and plug them and switch them. So 2 is going to go to port number 3, and 3 is going to go to port number 2. So for this, when I pull back on the stick, I want both parts of the V-tail to go up. That's right. And when I go right, what I'm going to want to see is I'm going to want to see the left, what do we call this, taileron? I'm going to want to see the left surface deflect upwards and the right surface deflect downwards. What that's going to cause is going to be a little bit opposite of typical elevons. This is going to actually cause the tail to shift this direction here. V-tail mixing works the exact opposite of how you'd expect elevons to work on a wing. Our next step, while the motor is powered and everything's moving around, we're going to make sure that the motor is spinning the proper direction for our prop. Now on a pusher, no matter where the prop is orientated, we always need the numbers facing forward towards the nose. And since the leading edge is here, we need the leading edge to turn in this direction. This is a conventional prop. So what we need to look is make sure that the motor is spinning the right direction. And it's not. To reverse the motor, we're simply going to go ahead and disconnect two of the lines, any two, and swap them. Now when we fire up the motor's spinning in the right direction. At this point, we can go ahead and disconnect our battery, and we can install our propeller. We're going to go ahead and be careful to make sure that we use the proper bushing, which is going to be this one right here. That's going to keep our prop nice and tight against the shaft without wobbling back and forth. Since it's a pusher, it's going to go into the back side here. So we're going to go ahead and press on our bushing. Don't be surprised if it's a little tight. Kind of turn it down like it's a prop nut until you get some exposed threads. Once you have some exposed threads, you can take your prop nut, thread it on, and make it do the rest of the job. Once it's nice and tight, go back with a piece of wire, tighten it down. Our next step is to route our wires. Now for this, I'm going to want my antenna sticking out the bottom. So I'm going to go ahead and put a little drop of glue, and I'm going to fix this right below the CG line. You can move this a little bit forward, but we're going to have this area for our batteries, and eventually I'm going to switch this over to FPV, which means I'm going to have some FPV gear up here. So I'm going to go ahead and put a little drop of glue. You can also use double-sided tape. I'm going to go ahead and press this down just behind the thumb hole. That way I can route my wire right down through, not the bottom. Now take my additional wires, give them a little bit of a twist and tuck them down. If you want to keep everything nice and neat, just take a little piece of tape to hold it in place. Now this is one thing I want to be a little bit transparent about. Because this is a pusher and the motor is so far back, unfortunately this wire is not very long, which means you're going to have a little bit of difficulty in getting it plugged in. Sometimes you may even just pop the two rubber bands and make your connections and put your wing back on. You can always solder an extension and make an extension for this, but it really only takes about 20-30 seconds and you're back up in the air because the rubber bands are captive. We're going to go ahead and install our wing now. And we're going to go ahead and establish our balance point for the plane before we make our connection. Now this works very, very well off of a 1000 milliamp 3-cell, but what we have in our store is our 800. So I'm going to go ahead and show you how to balance the plane with an 800 milliamp 3-cell. Now if your motor shifted too far back or you're using a bigger motor than what we talked about, you may need a little bit additional weight. But just as Adam and I in the early part of the video was using a little bit of clay in the very tip of the nose to give you the proper balance, we can do the exact same process. It's very economical and very easy, and can also be removed very quickly. So I'm going to go ahead and pop this area open here. I'm going to set my battery pack down in, and I'm going to slide as far forward as I can possibly make it go. On the very bottom of the wing, you're going to see two little circles. Those two circles are going to be our balance points. So when we hold this up, we can see where our balance is. Now you can see right now that it's a little bit tail heavy. We can either remedy that with a bigger battery, or I'm actually going to take some of the clay that we removed from the design when it was chuck lighter and put it back in. You're not going to need any clay or nose weight if you're using a bigger battery or if you have an FPV camera up in the front. It all depends on the equipment that you put in. But I really like using clay. It gives a nice solid nose and it's easily removable and adjustable. Let's go ahead and put that up in the front there. We'll go ahead and put our battery back in. She balances out fantastic. I like it when I have my fingers on the two dots for it to be just a touch nose down. That tells me that it's definitely on the nose heavy side rather than the tail heavy side. Now that we have our balance established, we're going to go ahead and remove our wing and we're going to make our connections. We'll turn on our transmitter and we want to make sure we have the proper throw. We have a little included throw gauge here, And if you use the smallest servo horns like we recommended, you're going to notice that the controls are already dialed in very nicely. We're going to go ahead and put our throw gauge on. We don't need a whole lot of throw, so we're going to go ahead and make sure our deflection goes up and just meets the edge. Well friends, our throws are dialed in, our balance is perfect. Let's go ahead and put the wing on and take it for a flight. Alright, the FT Mini Sparrow is all balanced, the control throws are ready to go. Next thing to do is fly it in this crummy winter weather. Alright, let's give it about half throttle. Alright, let's wind it up. So this is just powered off of a little tiny A motor, and it does fantastic. Even though it's a 3-channel, the yaw control gives you very nice coordinated turns. Slow it down a little bit here. We got about 10 mile an hour, 15 mile an hour winds today. It does get bumped around a little bit, but it does very well. Feels like you want to race these things, doesn't it? Friends, I want to thank you for watching, and whether you're building this as a little simple chuck glider or to learn some techniques for future builds, or you want to make a fun little 3-channel ship, I encourage you to check out this machine. As always, the free plans and of course this build video will always be free. If you guys want to make the time shorter or build with an educational group, check out our store, and also look for FT STEM and FT groups to be launching very soon. We're already taking schools in, and I can't wait to introduce FT groups to you. We'll see you next time.